Hello guys and welcome back again. So in this lecture we'll talk about valency and how can we calculate the valency of an every atom in a few minutes or few seconds. So let's talk about valency. So here I have written there are two definitions of valency. So first one is our the combining capacity of an atom with other atoms is called valency. So it means that one atoms combined with how many other atoms, so that is its valency. From here, that is compound, that is magnesium chloride, aluminum chloride, that is methane, NaCl and SiH4. So from here we can simply tell the valency of this magnesium, aluminum, chlorine, CH4, NaCl, Si and H4, because so the valency is the combining capacity of one atom. It means magnesium, for example, with other atoms, so that is called valency. So here tell me, magnesium combined with how many chlorine? 2 chlorine. So the valency of magnesium is 2, and 2 chlorine here, that is aluminum combined with how many chlorines? That is 3 chlorines. So valency of aluminum is 3. And in CH4, carbon combines with how many hydrogen here? 4. So the valency of carbon is 4. And in NaCl, let me give you answer. So NaCl, so that is sodium metal combined with how many chlorine? 1. So the valency of sodium is 1. So in SiH4, so silicon combined with how many hydrogen here? You can see here. So silicon combined with 4 hydrogen. So the valency is our 4. So in this way you can calculate the valency of a atom from a given compound. For example, like that MgCl2 2, AlCl3 3. So in here you can see if chlorine, 2 chlorine combined with 1 magnesium, so the valency of chlorine is 1, because valency of magnesium is 2. So in this way you can easily memorize, you can easily tell the valency of atom in a compound by seeing just structure. And it is when your valency come in your exam, you can write this definition and you will get 100 marks, and it means full marks. But now second definition is here, the number of electrons lost or gained by atom during chemical reactions is called valency. So if you understand this second definition, then you understand this valency in details clear way, because from here not clearly seen, because you cannot calculate the simply the valency of here chlorine, because not compounds are given here, atoms are given. You have to tell the valency of atoms, not any compounds like NaCl. So tell me the valency of Na. So in that case you cannot use this trick, because in that case you have to find the valency of individual atom. So in that case you use this definition for conceptual, that is the number of electrons lost or gained by atoms during chemical reaction is called valency. So the how much atoms, for example in NaCl, so it is a molecules. So in this molecules how many atoms here? 2 atoms, that is sodium atoms, and here that is chlorine atoms. So tell me here, so according to this definition, so this formation of this substance, that is NaCl, so how many electron lost by sodium during the formation of NaCl? So that electrons, that number of electrons is called valency of sodium. And in Cl, how many electrons gained by Cl during the formation of NaCl? So that number of electrons is called valency of Cl. So this is the one of the conceptual definition of the valency. So let's talk more about this definition. Okay, so before understanding this, Second definition, that is the number of electron loss or gain by electron during chemical reaction, during atom chemical reaction, is called valency. So before understanding this definition concept of valency, so we have to understand octet rules as well as duplet rules, because there is a typical questions come in your exam, state octet rules and state duplets rule, and that is really conceptual ones. So let's see about octet rules. So what is octet rules and what is duplet rules? Okay, octet rules here, octet rule and duplet. Okay, so first one is our duplet rule, because 2 comes before. Okay, and second one is our octet rule. So before understanding valency, so we have to understand two rules, that is duplet rules and octet rules. So according to duplet rules, so it means, here you can see from here names duplet. So listen here, duplet, du means 2 and oct means 8. So duplet, here duplet rules, so it means that an atom which possesses 2 electrons in their last shell is generally stable. So that rule is called octet rules. So listen one more times here. Octet duplet rules states that the atoms which possess 2 electrons in their valence shell, last shell, which is most stable forms, so that rules is called duplet rules. So every atoms, and this rules is followed by only one atom, that is helium. So in helium, if you see structure, atomic structure of helium, then that is here, that is proton, and that is neutron. So in helium, and that is cell. So how many electrons? So the atomic number of helium is 2. So the atomic number is 2. The number of electron is also 2. So we have to put 2 electrons in cell, and this is the first cell, that is K cell. So capacity of K cell is how many electrons? 2 electrons. So here I am going to put 2 electrons. So that these helium's atoms possess 2 electrons in their outermost shells. So the helium is a stable one, and that rules is called duplet rules, and that state of the helium in which they possess 2 electrons in their outermost shells, so that state is called duplet states. Duplet state, clear or not? So that state is called duplet states, and that rules which governs 2 electrons in their last shell, and it is only followed by only one atoms, that is helium. So that rules is called duplet rules. So then talk about octet rules. So what is octet rules? So its name suggested, octet means 8 and rule. So every atom wants to gain, listen here, so every atom wants to gain 8 electrons to their outermost shell to gain their stability, and that rules is called octet rules. So every atom wants to gain 8 electrons in their last shell, and that rules is called octet rules. So when we calculate the valency of an atom, we have to remember that is octet rules. So listen here, for example, so I am drawing here atomic structure of sodium. So atomic structure of sodium, that is here. So sodium Na, atomic number 11. So atomic number is 11. So number here, that is first one is our nucleus. So inside the nucleus, that is proton P plus. So atomic number is 11, that is the number of proton is also 11, and if you see chart, the number of neutron is 12, no charge. So first cell, So we have to put how many electrons here? 11. So in first cell how many? 2. In second cell how many electrons? 8. 1, 2, 3, 4, 5, 6, 7, 8. And in third cell how many electrons left? Because we have to draw one more extra cell, because in L cell the capacity of L cell is how much? 8. K cell is 2. So we have to draw one more extra cell, that is this cells, and this cell have only one electrons, because total electrons number is 11. So 281. So 281. So it means here in first cell 2 electrons, that is in K cell. In L cell 8 electrons, and in M cell 1 electrons. So from octet rules, listen here. So the valency of sodium is 1. Listen. Why? Because from octet rules, what is the statements of octet rules? Every atom wants to gain 8 electrons to their outermost cells. So here, if you see the structure of atomic structure of sodium, so let's see here, that is in first 2 electrons, that is complete. In second, that is 8 electrons. So if sodium lost 1 electrons, listen here, if sodium lost 1 electrons, then what will happen here? They gain which states? That is 2 and 8. So this state is fulfilled. This state is more stable, because the rule of octet. So the octet rules states that every atom wants to gain 8 electrons to the outermost cell, and that is called octet rules. So according to octet rules here, if sodium lost 1 electrons from outermost cell, then they will easily get octet to 8 electrons in their last cell, and every atom wants to gain their stability, like human also wants to gain stability. So in the same manner, every atom wants to gain stability. So if sodium lost 1 electrons, then it possesses electronic configuration 2 8. And according to octet rules, if atom possesses 8 electrons to their last cell, so it is most stable form. So the valency of sodium is 1. And tell me, sodium loss or gain electrons? Okay, tell me here, sodium loss or gain electron? Lose or gain? That is lose. Yes, how many electrons? 1 electron. So the valency is -1. Clear or not? Sodium lose electrons to gain which electronic configuration? 2 8, and so the valency of sodium is 1. So the valency of sodium is 1. So let's talk about one more example, that is chlorine. So the why the valency of chlorine is -1, and let's talk to clear your concept. So that is here chlorine. So here chlorine, so atomic number is 17. So it means that how many electrons here? 17 electrons. So we have to put 17 electrons by drawing this structure. So first one is our nucleus. So inside the nucleus, that is protons and neutrons. So here I am not writing numbers, okay, so don't worry. Protons, so here's 17, and you can see the chart one time, and you can write here, that is neutrons. So here, okay, so here that is 18. Okay, so here 17 protons and here 18 neutrons. So this is the nucleus. So now we have to draw extra cell, that is first cell, that is called K cell. So in K cell how many electrons? That is 2 electrons. So if I minus here 2, then remaining is 15. So we have to put 15 more electrons in the cell, that is L cell. So the capacity of L cell is how much? L. So we can put only 8 electrons here. So 1 2 3 4 5 6 7 and 8. And now questions come in your mind, that is KL and M cell is capacity 30, sir. 32. Sir, we can put 32 electrons in M cell. No, don't make this mistake more times. Now, because if you drawing atomic structure, you have to remember octet rules, because from octet rules every atoms in their last cell wants to occupies how many electrons? So 8 electrons. So you have to recall which one? Octet rules. So the in M cell not 32 but only 8, because from octet rules there is if the atoms possess 8 electrons to their last cell, it is more stable. So here that is you can see 8 to, if we minus here 8 then becomes 7. So in last cell that is we can put how many electrons? 7 electrons. 1 2 3 4 5 6 7. So now questions come in your mind. So listen here. In chlorine, atomic electronic configuration 287. 287. So tell me, either chlorine lose 7 electrons to gain this electronic configuration, or gain 1 electrons to become this electronic configuration. Okay, which one is more easy? Tell me. Losing of 7 electrons is more easy, or gaining of 1 electrons is more easy? Tell me. Losing of losing of 7 electrons here, that is a loss of 7 electron, is more easy, or gain of 1 electron is more easy? Which one is more possible? Yes, the gain of 1 electron is more possible, because in chlorine that the last cell possesses how many electrons? 7 electrons. So if chlorine gains 1 electron, then their electronic configuration 288, and this is established by which rules? Octet rules. So the valency of chlorine is not 7 but 1. Okay, tell me, they gain or lose? So they gain. If they gain, then minus 1, and if they lose, then plus 1. So the valency of sodium is plus 1, and the valency of chlorine is minus 1. Due to octet rules, the chlorine possesses 7 electrons, so she wants to gain 1 electron, either losing 7 electrons, because it is easy. So thank you so much for watching this video, and I hope your concept cleared from this idea, and thank you so much, and we'll make more videos from for chemistry. Bye bye, take care.